Every positive integer has a unique prime factorisation. One way to find a unique prime factorisation for a number is by using a factor tree. For example, suppose we wanted to find the prime factors of 60. Well, to start off with, we pick any pair of factors of 60 that we can think of. So 60 is equal to 10 times 6. So I can write those two factors down. Now I just do the same with each of those. 10 is 2 times 5. And notice that both 2 and 5 are prime numbers, so I can't factorise them. So I'm going to stop there. And 6 is 2 times 3. And 2 is prime, and 3 is prime. There's no more branches I need to carry down, so I've finished. And I can say that 60 is equal to 2 times 2 times 3 times 5. Now, you might have wanted to do your tree differently. You might have thought, well, 60 is actually 4 times 15. That's fine. You just have to pick any two factors of 60, any pair of numbers that times together to give you 60. And then I do the same thing. 4 is 2 times 2, and 2 is a prime. So I've reached the end of my branch, and 15 is 3 times 5. And even though my tree looks different, when I get to the bottom of it, I get the same answer. 60 is 2 times 2 times 3 times 5. That's what is meant when we say that every number has unique prime factorisation. It means there's only one way of writing that number as a bunch of prime factors all multiplied together. Or your tree, you might have thought, well, 60 is 2 times 30, and it is. 2 times 30, 2 is prime, so that's the end of what I can do on that branch. But 30, you might think, well, 30 is 2 times 15. So I can write 30 as 2 times 15, and again 2 is prime, and 15 is 3 times 5. And so 60 is still equal to 2 times 2 times 3 times 5. Your trees can look very different to another person's tree, but you'll always end up with the same final prime factorisation.